Hello everyone, in this video I bring you modeling of a parachutist motion. To model the motion of a parachutist, let us consider a parachutist falling at a uniform velocity v meters per second and acceleration of a meters per second squared. If the mass of the body, that is the parachute and the person in it and its luggage, is m kilograms, take the necessary assumptions and model a differential equation that shows the variation of velocity of the body with time. So let us assume this is a parachutist in his parachute with the luggage, and the total mass is m. So the forces acting on him is mg, which is as a result of the weight, and Fd, which is called the drag force, that is directly proportional to the square of velocity according to Stokes' law. So if that is the direction of the force, the drag force, because it is trying to oppose his motion as is falling down, then the acceleration, if the acceleration is arbitrarily taken to be down, then let us look at the forces. Mg is due to the weight as a result of gravity, and the Fd is a drag force due to air resistance, and according to Stokes' law, this Fd is directly proportional to the square of velocity. Therefore, Fd is directly proportional to the square of velocity, and Fd is equal to kv squared. But experiments with Stokes' law show that Fd is equal to Cd rho A v squared over 2, whereby Cd is the coefficient of drag, rho is the density of the air, A is the frontal area in contact with the opposing stream of air or dragging him upwards, then V is the velocity or the speed, the rate of change of distance of or height with the time of the person. Now it means that constant k is equal to CdP, rho, which is coefficient of this coefficient of drag times the density times area divided by 2. Let us assume it to be equal to k, because none of these values are going to change. This is a constant, this is a constant, that one is a constant. Now the resultant force is assumed also to be ma according to Newton's law of motion. Now writing the equilibrium equation would give us mg minus fd is equal to ma. If I take the difference, because I know one thing I'm sure is that this parachute is from maybe an aeroplane very far away in the sky and is going to fall down, but is going to be moving at a uniform velocity. So I know what I'm sure about is that mg is bigger than fd and is undergoing uniform velocity and uniform acceleration. If I take such assumptions, then mg minus fd will give me the resultant force. Now, the resultant force, having substituted in my equation, it means if I'm to take the variation of velocity, for example, I have ma equal to mg minus bv squared, kv squared. Now, when I substitute it in here, I know already acceleration is equal to dv dt. So it means m dv dt, if I bring them all this side, it will be a plus kv squared minus mg is equal to 0, as it is shown here. So since acceleration is the rate of change of velocity, if I substitute it in here, it becomes that m dv dt time plus kv squared minus mg, and if I divide both sides by m, Then this one will go, that one will go. Of course, this is also out of m, but remains 0. So I will have a differential equation dv dt plus kv squared m minus g is equal to 0. This is the first order ordinary differential equation and can be solved by separation of variables. We will see in the near future how to solve such an equation. Thank you so much.